So in this video, we want to talk about rendering particles, and be aware it's not about shading particles. That will be in the next video, because for rendering in general, you need to be aware of two things, and I wanted to separate, general rendering and shading. So the two things you have to be aware of when rendering particles is Pscale, so the size of your particles when you render them, and motion blur. So what I took here is my rain example, and it's nothing special, it's just particles coming from a grid and then falling down. And when I just press render on this, what you get is this. You get a render with massive spheres and one big sphere right in front of us. So let's make sure we get at least one more frame so that we don't have a single particle right in front of the camera. So what's going on here, and it looks interesting, but it certainly doesn't look like rain, is that as you can see, the particles are rendered as spheres. That is normal, but what is not normal is the size of the spheres. Of course, you need a sphere, by the way, because a particle by definition has no volume, so you wouldn't see anything, and this is why that makes sense, but you have to define the size of it. And this is defined by an attribute we already know, Pscale. Now, when we look at our simulation here, we can see actually that we don't get a Pscale attribute out of a pop simulation. So the size that you see here, I think in my case, is 0.05 meters, but I figured the number is actually random based on some kind of arbitrary calculation or whatever, but it's basically always wrong. So just make sure when you render particles that you set the Pscale attribute. And of course you can do that with create attribute or with WOPs, or of course how I do it with a point wrangle, because it's the easiest and quickest in my opinion. So what we want to change is the Pscale attribute, which is of course a float. And we set it to, let's start with 0.01 meters. And let's save this render and see what happens. And as you can see, they're much smaller. So before it was bigger. So it's quite simple now. Just make sure you find a number that makes sense to you. So in my case, maybe 0.05 could make sense. Yeah, that's not too bad. Okay, so it might be a bit too big depending on your case, but this way we can actually see it on the video. So the next thing is, if that would be rain, there would be something missing. And we already talked about this, motion blur. So basically the way we faked this before was with a trail node, but let's now do it properly in rendering. So we want this kind of, streakiness that comes from the movement of the particles. Now what we need for that is velocity, and we already have velocity on them, which we can double check in the attributes, but we can also just check it in the viewport by turning on this guy here, which shows us there is certainly velocity. And this is what we want to be represented in the motion blur. To make this work, we need to do two things. We go into our Mentor node, and under rendering, we say allow motion blur. And if we now render this again, we can see that nothing has changed. Why the hell? The reason is that this is not enough, unfortunately. You don't only have to turn on motion blur on the ROP, but unfortunately, which personally annoys me a little bit, is that you have to go on every geometry node that you want to render with motion blur, and under sampling, you have to switch geometry velocity blur to velocity blur. So you have to basically tell the geometry node that it should use its velocity attributes to calculate the motion blur from it. The reason for this, by the way, is historically because back in the day, the Mentor node kind of calculated velocity blur automatically. But this created so many problems and errors that side effects turned this off. But what they didn't change is that you still have to turn it on as an kind of, what was an alternative before is now the only way of doing it, which is good because it's the only proper way of doing it. But this is why you have to remember to always turn it on the geometry node. And we will see this time and time again outside of pop simulations. For any kind of rendering, you have to turn on the velocity blur on every geometry when you want to use motion blur in the first place. And if I render now, you will see now we have a motion blur. So again, two things you have to do on the ROP and on the geometry node, you have to activate it. And what you can see, this is typical, this has nothing to do with Houdini really. As soon as you use motion blur, it will be very noisy. That has to do with the fact that there are basically transparent, let's call them, objects that are rendered basically. And this just means that the calculation will be less correct when you have a relatively low sampling number. So all you have to do really here is increase the pixel samples, and I go pretty high here with 12, and let's turn off the progressive rendering here, and you can see now you have relatively soft motion blur. So don't be surprised when you use motion blur, you need higher samples, camera samples. And of course, naturally, that means whenever you render with motion blur, the whole thing will be slower. One tip I would give here is usually what you often do is you take the stuff that has the highest motion blur and render as a separate pass so that you don't have to render everything with such a high sampling rate. But, you know, I don't want to go too deep into this. Just a quick tip. So, okay, so here we've seen the two things that you have to remember when rendering particles. Set the Pscale attribute and make sure that your motion blur works by turning it on in the ROP and on the geometry. All right, thanks very much and see you later. Cheers.